Hello and welcome to this video. In this video, I'm going to configure VTP on these two switches. Basically, I'm going to configure VTP on only one switch, and then automatically, the VLAN information will be propagated from this switch to the switch that I have here, switch 2. So, basically, when you are configuring VLAN, you have to configure VLAN let's say VLAN 10 here, VLAN 20 here, and then you have to move jump to this switch 2 to configure VLAN 10 and then VLAN 20. Now, with the help of VTP, VTP will ease stress on network engineers, where you configure VLAN information on one switch and then it's being propagated to the other switch. So I have these devices turned on, and I have an IP address configured for the various PCs, and as you can see, PC1 is configured to use 10.1, and then the PC2 is configured to use 10.2, and I think test will work because they are in the same subnet. And then by default, every switch on every port on the switch is configured to be in VLAN 1. That's the native VLAN. That's why they are able to talk. And then from our previous video, if you watch how I configure the VLANs, the moment a port is switched to a different VLAN, irrespective of both devices being in the same subnet, communication will not work until they are in the same VLAN. And I said VLAN is used for network segmentation. Okay, so I'll go ahead and then configure VLAN. So I'll first do show VTP status, that is virtual tracking protocol status, and then it's transparent. The mode is transparent, meaning when a VTP a switch is in the VTP mode transparent, it will not propagate VLAN information automatically to the other switch. So first of all, what we have to do is configure VTP mode, and I will explain the modes to you. So first, I'll type VTP mode and question mark. The client over here can only receive VLAN information from another switch, and aside that function, it cannot perform any other function. Mode off means that there is no VTP running on that particular switch. A VTP server can create VLANs, delete VLANs, and then propagate VLAN information to other switches. And transparent 2 is just like setting a VTP mode to be off, so it cannot propagate VLAN information. Neither can it create VLANs or transparent can create VLANs, but it can't propagate VLAN information to other switches. So at the moment we are at transparent, and I will set it to server. So when I do show VTP status, our switch should be in our VTP mode server. Do show VTP status, and as you can see, our VTP configuration mode is server. Now I'll do show interface trunk. At the moment we have no trunking interface configured on our switch, and VLANs travel on trunk interfaces. So I'll also check our interface connecting to switch 2, and it's connected on Ethernet 0100. So I'll do show interface E00 switch port. Okay, let me drop to privilege mode, and I'll do show interface E/0 E00 switch port, and the administrative mode is dynamic auto. When the administrative mode is in dynamic auto, VLAN information cannot be propagated automatically. I'll talk about the modes when I get there. And then we have operational mode, static access. At the moment, our port connecting to switch 2 is an access port, and therefore VLAN information cannot travel along that port. At the moment, auto negotiation is on, and it means DTP is running, and as you can see, it's in access mode VLAN 1 by default. So we will go ahead and configure our trunk interface. So I'll do config T, and then I'll do interface E0/0, and I'll do switch port mode, and I'll explain the modes over here. Access mode is just for the native every port on a switch is in access mode until you turn a port to be in the trunk mode. Access mode is for just transferring default network traffic other than trunk. And then so we have the queue channel, and then we have dynamic. The dynamic here will set the port to auto propagate VLAN information to the nearby switch or any switch connected directly to its interface. So I set it moves to dynamic desirable. So I'll end it, and then I'll do the encapsulation. It's very important. Switch port encapsulation. Okay. So I had to erase it. So I'll draw back to privilege mode, and at the moment I'll do show interface trunk. And as you can see, we have automatically trunk has been set to PC2. So Ethernet 00 on switch 1 has been automatically configured as a trunk port to switch 2 over here. So I'll go to switch 2, and as you can see, the trunk information has reached switch 2, and then ETA went down and is up, and it's currently a trunk port. So at the moment I'll do show VLAN brief, and as you can see, we have our native VLAN over here. VLAN 1. So I'll do show VTP status, and it's transparent. And at the moment, this switch is in a transparent mode. It's not accepting VLAN information from our switch 1. So let's go to switch 1 and configure VLANs on it. So config T VLAN 2, name sales, config T VLAN 3, name IT. So I'll draw back to privilege mode, and I'll do show VLAN brief. And at the moment we have 2 VLANs configured over here. So I will go to switch 2, and I will do show VLAN brief. And then we have only one VLAN here. We have only one VLAN here because the VTP mode running on this switch 2 is transparent. So the moment we change the mode to either server or client, the VTP information on switch 1 will automatically sync with switch 2, and then we will be able to have VLAN 2 and then VLAN 3 over here. So before that one, I have to configure a very important thing, and I have to configure VTP domain, and it's very necessary. So I'll choose on CCNA. So to CCNA, okay, that's already been set. So let me go ahead and configure this switch to be in VTP mode client first. Mode client. And let's see what happens. So first, there were no VLAN information being propagated from switch 1 to switch 2, but now we should see VLAN information from switch 1 to switch 2. And as you can see, there is it. And as I said earlier on, information from switch 1 will automatically propagate to switch 2. And then I talk about the VTP modes. We have a server on switch 1 and then the client on switch 2. Now, what I was saying was client and VTPs cannot create VLANs. So let's look at this one, VLAN 4. And as you can see, VTP VLAN configuration not allowed when the device in the client mode. Now let me change it back to VLAN server VTP mode server, and at the moment we should be able to configure VLANs on switch 2 and then it will appear on switch 1. So I'll configure VLAN 4, name domestics. Name domestic, and I should be able to see VLAN 4 available. So VLAN 4 domestic available on switch 2, and then let's take from do show VLAN brief, and there you go, we have 4 over here. So I will do show VTP status. Okay, so at the moment we are operating in server mode. When you go to switch 2, show VTP status, we are also in server mode. We have 8 existing VLANs and the configuration revision number is 3. And also we have 8 VLANs existing and the configuration revision number is 3. So at the moment we have 8 VLANs running, and there we go. So that's how to propagate VLAN information using VTP. That's basically what is being used for from one switch to the another. So I'll go ahead and then change the VLAN of so PC1. So interface Ethernet 0/1 switch port access VLAN 2 switch port. Okay, so I'll do show interface E0/1 switch port, and as you can see, it's in VLAN 2 and the trunk mode is in VLAN 1 by default. So at the moment PC1 shouldn't be able to ping PC2, and that's it. The moment a port is switched to a different port, irrespective of the devices being in the same subnet, they can talk to each other. Okay, so that's how you propagate information or VLAN information from one switch to the another. And then in our next video, we will configure this complex topology right here. Thanks for watching.